Welcome back, students. In today's video, I want to go over another couple of examples of elastic collisions. In the past video, I went over an example where there's two objects colliding with each other. The first one had some velocity and then the second one was at rest. And then after they collided, they both were moving towards the right, both in the same direction, and they had different velocities, but we were able to calculate the velocity of the second object after the collision with knowing the conservation of momentum equation. Okay, we're going to use that same equation to do a couple other examples, but there's two other possibilities for elastic collisions that we're going to talk about. The first one being something you might see in pool where all the objects have the same mass, so whenever you hit the white ball and hit another ball, sometimes the white ball will totally stop after the collision and all the momentum will transfer into the ball that you hit. I'm going to go ahead and go through that example right now. Let's say we have two balls, both of the same mass, 10 kilograms. Okay, here I've drawn out an example, kind of like the pool example, where the first one has velocity, the second one doesn't initially. And I've given you the momentum of the first object, and since we know that the second one's not moving, we know that its initial momentum is 0. And then after the collision, all of that momentum is transferred into the second ball. The conservation of momentum tells us that the momentum initially equals the momentum finally after the collision. So I'm going to write that up. Okay, this just states that the initial momentum for both those objects equals the final momentum for both those objects. And since I know that the first one was 70 and the second one was 0, and I know that this one was 0 after the collision, I know that the final momentum of the second ball is also going to be 70. Okay, and if I wanted to solve for the velocity of that object after the collision, it would just be one more step. I would have to write out the momentum in terms of its mass and velocity, so that would look like this. Okay, so writing out momentum in terms of mass and velocity, I know that 70, the momentum, is equal to 10 kilograms times the velocity. And if I wanted to solve for the velocity, I just need to divide both sides by 10. And then I know 70 divided by 10 is going to be 7. So then I solve that the final velocity of that object is 7 meters per second. And since I know that they all have the same mass, I also know that the first object had to have 7 meters per second as a velocity as well, right? And I know that in elastic collisions, my kinetic energy is conserved, so all the kinetic energy that was in that ball remained in the system, is just in this ball after the collision. Next, I'm going to go through an example where, in a similar situation where the first object has some velocity and it runs into a second object that is just stationary, but instead of transferring all of its momentum into the other one, in the second example, they're going to be moving apart from each other after the collision. Okay, here I've done another example where I have two cars colliding. The first one has a mass of 600 kilograms and an initial velocity of 4 meters per second, and then it's colliding with a stationary, bigger vehicle of 1,000 kilograms. And then after the collision, the first car kind of bounces backwards and it had a velocity of 0.8 meters per second, and I use a negative to notate that it's going the opposite direction as it initially was. And then the second object, which used to be stationary, then started moving to the right in the positive direction. And I want to solve for how fast it was going, the velocity. Okay, I'm going to go ahead and write out the conservation of momentum. Okay, next I'm going to plug in my numbers for everything I know. Okay, now so I've plugged in all my numbers. I'm going to go through each one. I know that the mass of the first one was 600, the velocity was 4 meters per second. And then for the second object, the mass was 1,000, and the velocity was 0 because it was stationary. And then after the collision, I know that the first one bounces back. It has the same mass of 600, and the velocity was then negative 0.8. And then for the second object, I'm trying to find that velocity, so I have an unknown variable still, but the mass is still 1,000. Okay, doing the math now, 600 times 4, okay, this is going to be 2,400 kilogram meters per second. And then 1,000 times 0 is 0. Okay, and then 600 times negative 0.8 is negative 480. And then I still have my unknown variable here. If I'm trying to solve for velocity, I need to first get rid of this term. Or since it's negative, I'm going to add 480 to both sides. Okay, that cancels with this 480 on the right side. And then I'm going to add 480 to 2,400. Alright, and this gives me 2,880. Alright, and then the last step would be to divide this 1,000 to both sides since it's being multiplied. So then if I do that, it'll cancel here. 2,880 divided by 1,000. Okay, and this comes out to 2.88 meters per second. Okay, so those are just two other possibilities of elastic collisions that you're going to see on the form. But just to review, we're not doing anything different for any of these. We're still using this equation. It's just recognizing that like whenever something goes the other direction, it's going to be negative velocity, so you have to use that negative. And then if something is stationary at any point, then the velocity is going to be 0. That's the reason we're going through these different examples where they bounce off in different ways. Okay, anyways, I hope this helps you get through that Google form, and we're going to get through inelastic collisions next to finish up the unit. Okay, see you guys next time.